Hey guys, welcome to the next video of step by step data science. So today we are going to focus for the beginners. If you are beginners who wants to try data science, who wants to switch career to data science and don't know how to start, which project to initiate, then this project and this tutorial is for you. Today we'll be talking about EDA, Exploratory Data Analysis, which is the core, which is the baby step for any kind of data science project, or you can say data analysis. Today we will be talking about the what data set is, how to find data set, and how to do EDA cycle, and we will try to do everything in the EDA cycle, importing libraries, having quick look to the data sets, doing statistical analysis kind of things, and descriptive, creating histogram and heat map and such kind of things. So let's start. Before that, we need to understand what data set is. So generally, to do analysis or to start data science project, you need to have data, right? So how do you get data? So to get data, we need to look for data set, or we can find data set, or we can create our own data set. So generally, so understand, data set is a structural collection of anything, that data that can be a people, organization, anything. So that is data set. So in a general way, we can say that data set is the collection of data, or data set is a folder for data. So there will be data, there will be the data dictionary for describing this data and who collected it, how collected, and the year it was collected. Such kind of information will be in data set. So where can you get that data? So generally there are many places you can find, but I suggest you Kaggle. It's kaggle.com. There you can find many data sets, or you can also find the same Jupyter notebook analysis or an advanced analysis, machine learning, everything in this. And next is for machine learning, especially machine learning data set, you can find it UCI machine learning repository. Apart that, you can try Google data set and data.org and many things. You can simply search in Google and you can find data, right? So now you know where to find data and what, right? Now the main thing is what is data analysis. Before understanding what is data analysis, we need to understand what data is. Generally, data is anything we have collected or we collect from self-observation or experiment. It is data. And there are two types of data. One, quantitative, and next, qualitative. So quantitative data is those data which can measure by tools like ruler, thermometer, temperature gun, everything. Qualitative data is something, that data which you need to feel it, like smell, sound. And if we ask you how many people are living in Nepal, then you can say 500 people or 1 million or 12 million, right? You can quantify it. But if I ask you why are they living in Nepal, then the answer you give is different from the answer and the person give, or it is totally different from the next person from different country. So it's based on qualitative, it's based on context. So that kind of data is called qualitative data. Generally, if you need to separate between qualitative or quantitative, you can simply see if that data can question how many, how much, how often, then that is quantitative. If that data starts with why or how, then it's called qualitative data. Now we'll talk about data analysis. So data analysis is simply a procedure or method for finding and meeting objective, the objective you set to achieve from that data. Your purpose might be finding something in that data, right? So that is data analysis, and it is totally a procedure. It totally follow a method. You cannot do haphazardly, because if you do haphazardly, the information you obtain from data analysis is totally not good. So what process we follow? There are many processes, right? There are a lot of process to do data analysis, but generally there is a cyclic term for data analysis. The first thing is the purpose. What do you do and the reason why. Then you start to bring some questions like what do you want to do, what are your objective, and then you go for data collection. You can collect your own data, or in this section for data collection you can look into Kaggle, UCI, machine learning repository, Google dataset, such kind of thing, and find the data. Once you have data, you start data analysis process. This inside this data analysis there is a small segment called expert data analysis. So that thing is a baby step for whole. After doing this, after finding out the results, you try to interpret it, you try to find something from it, you try to relate that based on your understanding or with previous topic or other, like doing research in the internet, such kind of things. After that, you do either reporting or you write that, tell the story using the data visualization concept and everything, and you disseminate with other people and you evaluate. All this process is data analysis. But inside this process also we have a small segment called data analysis, and this is expert data analysis. Here we have to do expert data analysis, right? Now today's we will be like taking data from Kaggle, and the data is related about the student alcohol consumption, social, gender and study data from secondary school students. So this will be data. Now, so in this data we will perform exploratory data analysis. So what is EDA? Expert data analysis. So expert data analysis is simply understanding data quality, its description, its shape, its pattern, its relation, and visualizing it for better understanding. Like expert data analysis was first introduced by John Tukey, right? And fun fact is that John Tukey is the person who created the histogram too. So he simply said that for exploratory analysis is the main things, is the main primary aspect of data analysis, or is taken as a foundation stone for entire data analysis. So if your EDA is wrong, your entire data science project is going to fall down. If your EDA is right, then your foundation is right, then your data science project is going to stand hold. Now, if you remember from the above figure, the first thing is our questions, our purpose, our objective. So today, for this demo version, we will try to find our objective. We'll just have one objective, and I'll talk about that now. So this is the snapshot of our data. Here we have school, sex, age, address and everything. This is all related to the alcohol consumption, right? So our objective here is to find the relationship between age and absence. We want to look if the age have some relationship with absence in college school. Like, okay, generally if you think 18 years old kid will be more absent or 10 years old. Like there is a concept called bonk, right? From home they say like I'm going to school, but on the way they go to movie hall. So that's bonk. So what is the probability of 18 years old kid doing bonk or 10 years old kid? Definitely that 18 years old kid has a higher probability of doing bonk, and once he is doing bonk, then there is a high possibility of being absent. So we want to find this relationship. Though our data is alcohol consumption, right? But we want to look into this age and absence. So remember here, we are not going with the title, the objective of this data. We are going with our own objective. We can do that one. Like if you start, like you have a COVID data set, right? It's like nowadays totally available in so many regions and it's being common, right? You in COVID data set, you don't always have to look about COVID only. You can go beyond that and look from the different objective, different perspective. That's what we are doing here. Our objective is now here will import libraries. So we are importing pandas library. Here we are doing import. Import is to import something libraries. We are importing pandas library as PD. Look, why we are doing PD is like giving nickname, right? Like calling someone like long name is difficult, then we simply call it. Like if you remember some like Hindi movies, like if you are from like familiar with Bollywood, then there is a girl named called Pooja, and she wants her friend to call by Poo only. So this is the same like concept. Like writing panda is like little bit more, so it's easy to write PD. So this pandas is a Python library which is used for data manipulation, like looking into data, like loading data, and looking any kind of manipulation. And this numpy is used for mathematical, and we are importing as np. And we are also importing matplotlib.py plot, right? Py is Python, plot is plot. So matplotlib is Python graphics library, or you can simply say it is used to plot the graphs, and we are importing a plt. We are also importing C1 library as SNL. So C1 library is also graphing library, visualizing library. The only why we are using diff is like it is more easy to use this than matplotlib. C1 library is built based on matplotlib. So if you look in the foundation of the C1, you will find all the codes, all the concept of matplotlib. So these are the we are importing libraries. So in each cell, like if you like shift enter, then that cell will run. Now this PD is our pandas, right? So our data is in .csv file. So we are using pd.read csv. If it's Excel, then pd.read underscore xlx, right? And we are storing this. We are using pandas library, and we are storing all our data as a data frame in df. You can name anything, right? But generally the culture is df. Like generally in mathematics the culture is naming xyz or pqi. So that's one. So our data is loaded now we will take a quick look to our data set. So similar to print, we will do df.head. It will give the snapshot of a data set, like it has 5 rows and 33 columns. Now if you want to look 15 rows, then see, now we are getting 15 rows and the column will be same, 33 column. Okay, we just want to look 10. Now we are getting 10, right? So to look the data set, we will use head function. Now why do we use head? Like sometimes we might see easy, it will be easy for us to how data is looking and if there is something missing or not. And don't be confused, like this dot means as we have 33 columns, all 33 columns cannot be adjusted in this screen. So there is like many items, right? Now we will now go for understanding statistics. Our data is stored in df, so we will try to find all the statistics of this one using describe function. Df is our data set dot describe. If you do this one, then it will give all this column name with count, mean, standard deviation, minimum value, 20%, 50%, 75%, interquartile range, maximum value, right? And this 50% is median value also. So for the age, the mean age is 16.74, so round up it's 17, right? Standard deviation 1.2, mean age is 15, max value is 22, right? And the median age is 17 years old. So for study time, mean study time is 1, median is 2, max is 4. The unit might be different, so for that we need to understand what data distance. But our objective is like age and absence, right? So its absence is like total count is, if you say a count is 649, right? So 649 is our data point also, yeah. So understand that one. Now our maximum absence is 32, minimum is 0 absence also, right? So this is how we find statistics. Now once we have that, we can look at the data types. Like age should be always in number, right? And name should always be in character or string. So to see the data types, we will use the info data frame dot info. Then it will give all the name of the column and its null count. If there is null, then it will show here is done. Null means missing data, and data type. Remember, Python always take string or numeric character as an object, right? It will take as object, and rest is called number. So age is numerical value, so this is in 64. Now if you look here, like school is written GP, right? This is string, so school is taken as object. Like if we are familiar with the C programming language, like or other kind of programming language, like there is like int, float, other kind of things, right? So similarly, int, float, character, string, here all the string or character is taken as an object. Now you are sure that the objective of your is to see the relation between age and absence, and both should be in integer. Both are integer, so it's fine. Let's move forward. Now look at this. Though we do not have missing value here, right? But we are checking it. As this is demo, so I am writing this one. Now this is print function. This is dir data frame dot isNull. So in Python there is a function called isNull. Its purpose is to see if there is null value. Null value means if something is missing. Like for this first 0 row, like if age 18 is missing and all is present, then in age we will have missing value as 1. Here it is null, but it will be 1, right? Similarly, so that's called null value. So we are using isNull function, and we are trying getting values, and we are summing it up, so that if how many null will be there, like if 5 null, then it will sum. If there are 5 null in 5 rows, then it will sum it up and it will print. So the first print is about this one. If we get here like 1 2 3 4 5, right, then we are going to main imputation. So if there is next concept like how to clean data, how to fill null value, there are mean imputation, median imputation, and there are other kind of imputation. But generally here I am giving you the basic knowledge of mean imputation. Look, in Python, if something is missing, then that will be treated as NaN. Like here, if age is missing, then Python will automatically keep here as NaN, right? So what we are going to do is that we are going to replace using the replace, right? We are using numpy now because we are going with mathematical, right? So we are using np numpy dot nan. We are going to replace nan with blank so that we can fill that, right? And we will fill na. Fill na is null values. We will fill na with data frame dot mean, right? We are filling it with the mean value of that data to df only. Df is our original data set, and where we are going to fill it, we are going to fill it in this empty area. So once we fill it, now we'll again try to find inspect missing value. Is null dot value dot sum, here is 0. So as our data doesn't have any empty value, we are good to go for further. Ignore this kind of things. Now we will start, like we already started EDA cycle, right? Now we will start EDA cycle in more graphical way. Now we are going to use C1 library. So we are using SNS dot dixplot is called histogram, right? Dixplot. And for histogram, what do we need? We need bin size and we need x value, right? So for x we are going to use data frame and age, right? This hist means true, histogram kd is false, and bin size means 2 means we are like having bin size of 2 and our color will be blue, and histogram kd will be age color will be taken as a black. So this is for histogram. And for easiness we are using plt. Plt is our matplotlib, remember the first library, right? So plt dot title will be age count. Plt dot x level will be age means x value. Plt dot y level count means our y. And once you do this, we are plotting this one, age count. Now here you can replace with any 33 column name. Like if you here replace with AVSENC absence, then it will start to count of absent. Now here, now you see the key error absent, so it might be due to AVSENCES, right? But I just use AVSENCE only. So if you see error, such kind of error, then don't be like tempted. Just try to find what you did mistake. The first one is like key error, so it might be your typos. If other mistake, then just copy this error sign, Google it, you will find the answer, because there are many brilliant mind people who are in the internet helping you to learn more, right? So now here we are doing absence, but the title we gave age count. Here absence, so try to change that also. So we have absence, AVSEN, absence count, right? And absence count. So if you look at the graph, we have an absence count, and it is like for here not age, it's like what will be here, absence day, absence. Say absence day. For those people who are absent for 10 days are around 50 to 100. Those people who are not absent in 0 days are like around more than 350. So this is how we do, right? Now let me change back to age only. Now here we see this is the for age. So here in this graph we see that there is a 15 years old to 22 years old. The more like there is more people of 17 years old, and then 16, and then 18, and then 15, and then 19, and then 20, 21, 20. So by this also we know like the age. Now we'll try to plot the scatter plot of between age and absence, because our objective is that, right? So SNS.scatter plot, look here, this plot scatter plot. So we are using SNS.scatter plot, and for x-axis we are giving df absence, for y-axis we are giving df age, and this is the graph. So x-axis is absence, y-axis is. From here what we see is that we try to find the relationship. Absence is like 0 to 30, 31, 32, right? Like in a month there might be 32 days. So 22 years old boy or girl has been absent to till more than 10 days, right? It is going beyond that 10 days. So it might be 11 or 12. Yeah. The maximum number of people who are absent, maximum age of people who are absent is like 70, right? Because it is going for like 32 days. Also there is some student who have been absent for 32 days, like whole month. And there are some people from the age group 21 who are not absent at all, and who are absent for more than 20 days. So the more group is constituted within 20 days, and like age also like 20, right? They are constructed in this side. So this is how we interpret scatter plot. Now we want to create line plot. We just replace scatter plot with line plot, give x-axis, give y-axis, and give data as df. See here, Here what we did is little bit different. Here we give x equals to df, right, and then square bracket and the column name. Here we haven't written where the data, but in this one we just wrote x equals to column name, y equals to column name, and we gave data as df. So this data is how SNS is taking data. If we are writing data, then we have to give this way, but if we are not writing this data, right, you can simply write here df and square bracket. If you want to access column, then you would do like this. You just remove data and it will work same like the above one. Now here we plotted line chart between age and absence. Now for box plot also we simply change line plot with box plot and give y data as. See, the placement of the data can be anywhere, it doesn't matter. What matters is like there should be 3 arguments for this SNS: x, y and data. Without this, how can you make box plot, right, or any kind of chart? Okay, and like for this plot we are giving color, his, KD and different kind of thing. We can also do for scatter plot also, line plot also, and box plot also. Now once we have box plot, we have a sex, female and male. We are plotting the box plot between sex, right, female and male. And if you see here, if you know how to interpret box plot, you are fine to go. But here we see that most of our data is constructed between 16 to 18 years old, and the average age in both sex group is 17. In male there is an outlier who is having age 22 years old. Outlier is like having extreme age value beyond this one, and our data is like our data is equally divided in both male and female from 16 to 18 years, right? So this is the box plot. Both are in same concentrate, and our median age is 17 years old, right? This is called 50% interquartile range. This is 75%. This is 25% interquartile range. Now next come like we are trying to find the relationship between, right? So from here we see that age and absence are related, but there are some outlier extreme values for like 20, this one. Here also we saw that there is an outlier or extreme value. Now we are going to see more in detail for the relationship. For that we are using correlation matrix, and we are using heat map. We are using Pearson correlation matrix in heat map, right? So for that we are using CoreMat. You can have any name here. This is just like correlation matrix. For that we are using df and core function. So core function is already defined. Once you use this, it's defined, and we are giving f and ax as this is matplotlib. Subplot is our figure size will be 16 to 12. This figure size means how big you want this picture to be shown. And SNS heat map, we are using heat map, right, SNS, and we are providing this. To use Pearson correlation matrix, we are using core function, and that core function is stored in CoreMat, and that CoreMat is given to the SNS heat map, and its vertical max is 0.8 and its square equal to square means distance square, right? And once we do that, we get this plot. Here all column name will be on the left side, all column name will be in the x-axis and y-axis. It will be same. The color coding is that this line is means highly related, this dark means less related. To self they are always highly related, right? Age is always related to age. Similarly, absence is always related to absence. Now here we see age, red color falls between like 0.4 to 0.2, right? This color, this is related to failure. So what we see is like failures and age have slightly like kind of relationship, because it is above 0.2, and below 0.5, right? This one, failures and G1, G2, G3, they are totally not related because it is coming dark side. Now our target is to see age and absence, right? So absence and age, if you see here, like which color is this one? This one is like falls under 0.2 and minus 0.2 and 0.0, this side, right? So they are not highly related. Now this color code might be sometime problem, so we are going to find values. For that we are going to use same thing, PLT figure is figure size 20 by 20. Now we are making big image to see is this tiny image, right? And we are giving title, and similarly for that one we are using column map, but here you are using diverging plate of column map and giving 10 to 220 and CMap is true, right? Now we are using SNS heat map, diff call, see here we use SNS heat map, we just bring their name, and but on the next one we are using diff call inside the heat map as an argument only. We can do that, and we are using CMap is column map, square as true, annotation should be true. If you write annotation false, then this value 0.27, this value will not be shown in the figure. And later in the 0.9, big image line color will be white, this line color will be white, annotation font size 2 bit. The text for this one is 2 bit, and we will be plot will show. Now we have a color coding also and the value coding also. Now it will be easy. See here we see that absence is 0.15, absent and age, right? 0.15 is like less than 0.25 and more than 0.00, so it falls under this side. So in above correlation matrix we print the number, and we see that age and absence have value 0.15, which is below the 0.25. This is the normal average, right? Because from here we are changing the color, right? This is like not highly related, so they are not correlated, or you can say they are not highly related. If they are highly related, its value should be 1. See here, the value is 1 between del and right? The color, like if you see color coding like Medu 0.65, right? 0.65 the color code, and it is slightly blue. This is highly like kind of highly related to feather. But if you look at the G1 and the failure, it's going to minus 0.38 red color, so they are not highly correlated. So at first we thought that having the age and the absence will be highly correlated, because like if 18 years you will have the option of bunk, and so they might bunk and they might be absent. But see here, age and absence don't have any relationship. So you can say that if it's like higher age and he or she have the ability to bunk, and then they are definitely going to be absent. That is not being proved here. So this is our expert data analysis, and this is complete. As our objective is, we have already said the objective, as our objective is made, we complete our EDA. Now you might ask that always we should have one objective. No, you can have as many objectives as you can, but you must have objective. Without objective you are just wandering, right? So now you see we can do each and everything here, like it took a long time, right? But there is another libraries, like I told you, there are great mind who wants to help you learn and grow. So there is another library called Pandas Profiling. It's called Pandas Profiling. Simply it is like library means like the one you downloaded, like the use here, like pandas, numpy, cbun. Similarly you import Pandas Profiling, import Pandas Profiling as pf or something, and just run single line of code after importing data. Then all this graph, all this chart up to heat map with the snapshot, everything we have done today will be shown by that one. We don't have to do anything. But as a beginner, I highly suggest you to download this Jupyter notebook, write try with your own data. Just simply change the data set from here and go with each process, try to understand, try to tackle with the error and everything, and you are going to have great career in data science. Once you now where data science come, or once you complete this one, right, now you will be like going to apply more machine learning concept and other kind of things on this data set. Now you have like more idea of what your data is, right? And you can have like we have 33 features or 33 column. You can have many objective, you can see many from many perspective, and then it will be easy for you to explore further. So EDA is the foundation of any data science project. So for now, like, thank you very much, and if you have any doubt or if you want any particular topic like to be shared from our channel, please write into the comment and we'll get back to you. Thank you and keep learning. Bye bye.